This is a Toyota 3UR block after 12 hours of rough machining. All the freestanding original cylinder liners has been removed. So now this is a hollow shell in preparation for the 6.8 liter conversion with Moly forged pistons and these proprietary heavy-duty wet sleeves. Remember, the parts that we remove from these are freestanding anyway. They don't get supported by the outside block walls. So removing them does not remove much strength on the open deck engine block anyway. But the wet sleeves that we put into these blocks, they are supported on these walls. So they're good for 1,000 horsepower, no problem. More than that, probably not, but 1,000 horsepower, easy. Before we do any final machining, we need to stretch relieve this block. So expect a few days before we continue this process. Let's continue our Toyota 3UR 6.8 conversion kit. This is the third machining stage. The wet sleeves have been put in. And the deck surface has been machined and copper O-ring groove cut and the copper O-ring installed. Now, we remove one side of the torque plate compared with this side. If you take a look at this. The reason why we emphasize on machining the block with torque plate on is that the ductile iron sleeves are so tough. Normal honing machining operations don't work if you don't put a torque plate on. That means you have to leave so much stock on it for honing that it's going to take days to hone. To make this process practical, torque plate boring, especially the last two cuts, is absolutely necessary. In our experiences, open deck engines, no matter whether it's this Toyota or other German vehicles, the distortion is roughly 0.02 to 0.08 millimeters. Some thin wall casting Mercedes engines, they have a lot of distortion with or without the torque plate. So torque plate machining is the only way we do this. We remove this so that you can see the quality of machining that we do. To go with this engine, we understand that majority of the Toyota 3UR owners, they want naturally aspirated large displacement. Some of them want supercharging, whether it's Magnuson or other brand. So what we do is we chose a set of pistons that's good for 800 horsepower. This is Moly forged piston made of 4032 aluminum. And this is fully coated with phosphate coating, graphite coating, first ring groove anodizing, and Cerakote coating on top. Of course, the main benefit of using the material called 4032 compared with these 2618 aluminum is that these have much smaller thermal expansion rate. And this is much closer to the ductile iron material that's used for the block. Therefore, you don't need that much piston to wall clearance. And that translates into no oil burning, within the service intervals. And there's no knocking, there's no cold start rattle of any sort. This is ideal for Toyota engines. Well, of course, if you want high horsepower on other builds, contact us. We have 2618 options available. In our experiences, pistons without any coating on the surface, generally they produce a lot of issue, no matter how precise you machine the block. Pistons like these, such as the top European brand, I think, the Italian IRP brand. This is the IRP piston for another engine. If you look at how special this engine looks, the detailed machining, the structures on it. And these pistons, of course, they still require a lot of piston to work clearances, but thanks to the coating and the special design, generally they don't knock. And in our experiences, they don't burn any oil on the engines that we built. So this is so much that we can talk about on piston at this stage. Now back to the 3UR block. After we remove this from the CNC machine, we're going to put it on a honing machine with the torque plate back on, and then we will hone each cylinder to the pistons that we chose. So this one is 0.530, another one is 0.535, and there's probably another one with 0.525. So we'll match each cylinder with each piston, so they have very consistent piston to wall clearance down to like a quarter of a thousandth of an inch precision at 23 degrees Celsius room temperature. And then we'll do a leak down test to show that the leak down value is consistent across all the pistons, all the cylinders. And then we'll torque down everything, and then we're ready to go. This red engine is going on a Lexus LX 570 in China. The owner wants naturally aspirated, and it wants to look absolutely normal, just like a stock vehicle. You open the bonnet, or you can look the hood. It looks absolutely stock. You cannot tell this engine has been modified extensively inside. When we put this engine on the engine stand, we'll show you the other materials they use, such as the Billy crankshaft, the Billy rod. Thanks for watching.